So in this video, I'm going to show you how to add a GUI screen, or also known as AppMode, because AppMode is the variable in the application source code which tracks the current user interface state machine. So you can go into states of different displays and go into sub displays as well. So if you bring up a dialog on the screen, then that's just like a sub state of the state machine. This slide, which you see on the screen here, this is in the docs directory of the application. So all of the videos which I've done, you'll find the slides or documentation associated with that in the documents directory of the source code. So this is the source file task_lcd.c, and all visuals occur within this particular source file. So you don't actually call things within this, functions within this file. What you do is you send messages to a task called task_lcd, and when it receives a message here, which is the queue LCD event queue, this then decides what to display on the display, or what to update on the display. So you send it a message LCD app mode to change the current app mode, and the app mode is the current state machine of the graphics interface. And so you can change to different screens by changing the app mode, or you can change to different subscreens such as dialogs within the screen, also in this area. There's just a list of app modes here. So this is to actually display the screen to start with, and then lower down I'll get to in a second, where you receive messages on updating a particular screen after it's been displayed. So in here it's just a list of deciding which mode we're currently in. So in this one, app mode tool buttons, or app mode dials, or app mode monitor. So these are all different screens that you can switch to within the application, and it just makes us a call to LCD display mode and then the name of the mode that you're going to. So this is all very similar stuff. So if you want to add a screen, you add an item to this list, doing the same thing, putting an else if and the decision as to what app mode you're in, and then the call to the function. But what you can do is, because there's a set of them here, you can change these to the ones in your application and then delete the ones you don't want. Or if you need more, you can add more items to this list. And I'll tell you, and the app mode definitions are in common.h, which I'll show you at the end of this. So that's the message to actually display a screen. And then to update a screen, you receive this message, which is LCD data transfer. So it sends you in the message the actual data that needs to go on the display. And so again, you just decide which app mode you're in, and then you call the function LCD display update mode, and then the name of the application. And the names don't have to be this, but it's nice to keep it consistent so that you know what each function is doing. And you just pass in the data, pointer to the data which has been derived from the message up here. And so that's the same for every single one here. So it's very consistent here. So again, you just add the additional ones you want, or you change the ones if you're changing an existing mode to do whatever you want to do, or you can remove any modes that you don't want to do. And all of the modes, all of the functions that you see in here are actually within this file itself. So if I scroll down, so here's one for displaying the toolbar buttons. And further down, I'll just get to the config one, because that's where it displays something which is meaningful, which can go through in this source code. So this is for display mode config. So this is when the application sends a message to say, okay, we're changing to this application screen. So you draw this screen for the first time. So you basically draw all the controls on the screen. The first thing you need to do is lock the hardware, lock the LCD screen. And because the SD card and the touchscreen share the same hardware, that's why we're making a lock here. So it prevents anything else from doing anything with the hardware while you're using the SPI interface, which is a shared interface, to actually update the display. And then you do test message reset, which clears. So if there's a backlog of messages to do with the screen, it clears those messages because you don't want a message from a previous screen to affect what's happening in this screen, because we're just changing to the screen now. And then this draw screen, this is a GUI control in itself, in that it displays a title bar and also displays a little X in the top right hand corner as like a close button to the screen, and it adds its own touch event there, and you'll get a message close screen if automatically if someone touches that. And the way I go for it, so it just draws whatever controls it needs on the screen at the location it needs the actual controls, and controls like this have a message associated with them, so you pass in the message you want to receive if someone touches that particular control. So it's all quite simple, line by line stuff to actually display a screen. And so getting down towards the bottom of this, so then at the end you have to make sure that you release the lock that you have on the hardware at this point. If you don't do that, then basically your application will lock up, because nothing else will be able to use the hardware at all. So you need to make that the consistent, clear the previous messages, lock the hardware, display when you want to display, and then unlock the hardware at the end. And that's the same for all of these functions, and I've put them together. So this next function here you see is the update. So after the actual display new screen, well, in the source code you'll find the update function that is associated with that screen as well. And as you can see, it passes in the data, a pointer to the data within that. And this is this actual function is different quite considerably to the previous function, because all this function is doing is updating the controls to display what data is associated with those controls. So you have to make a lock to the hardware again, because we're about to do some drawing on the screen, and then we have to decide. So when you receive a message for updating data on the control, it will have a target ID for each of the messages. So because you have a series of controls on the screen, now the order in which you drew those controls will be the target ID. So if you draw a text box first, then the target ID of the text box will be 1, and if you draw a checkbox next, then the target ID of the checkbox will be 2. And then then it's a matter of formatting the data which is associated with that particular pointer, and it's a linked list of data pointers, so you might get several of them coming up, which is why we're in a loop here, and we're going to step through each one. So each one we decide on in the loop whether or not it's associated with the control that we're looking at here. We format the data for the control, and then we redraw the control, but with the new data in it. So for each of the things on my display, on my config display, you'll see an update for each of those here, updating the data, but you may not get updates to all the data. So that's why we're in a loop, is to decide which controls are updated and just update the display of those controls. And again, when I scroll to the bottom, all you have to do at the bottom, so here it is going through the linked list, getting the next pointer, and it'll go through the loop. And then when it's finished going through that loop of data that's been received, you have to release the semaphore again. And again, that's very important. But displaying the screens and updating the screens is as simple as that. You just have one of these for each of the screens that you want to display. So this is common.h, and this is where the app modes are actually defined, the values of the app modes. And so here it is on the screen here, and this is the first app mode, and it has a value of 0 as it's the default app mode. And then each screen I have has a different app mode value, and the app modes are defined have to be unique. And I've used the upper byte of the app mode as being the actual main mode. And as you can see down here, I've got some sub modes, so where it goes into like dialogs within that app mode, I've put the sub mode as the second byte, so that it makes it sort of understandable as to whereabouts you are, and easier to allocate these modes and sub modes if you consider the first byte as being the mode and has to be unique, which is the display, and then the second byte as any dialogues within that display. Because on the dialogues within the display, that dialogue will have controls associated with it. So with the set clock, there was a series of text boxes, up arrows and up values and down values associated with it, and you don't want to confuse that between the main config screen and the sub screen. So this is a way of dividing the sub displays out of the main display.